Alright, we're going to be solving some trickier equations today using our fraction skills and our quadratic skills at the same time. So it's not any new individual skill here, it's about combining them in different ways to get a solution. So we've got this pair of fractions added together equals some constant, in this case 7. You haven't really got a method for solving these reciprocal functions, dividing by a fraction, but if we get rid of the fractions using some sensible technique, we can get this sorted. So this line, as well as being a fraction, you should know means divide, and to cancel out division we will need to multiply. So the thing to multiply by here is x plus 3. We'll also need to multiply by x take 2. I'm going to do that at the same time in a longer method, in a full method, so you can see all the steps. When you do this yourself you can skip a couple of bits out. So this first fraction here is 14 times by all the things I'm timesing by. So x plus 3 and x take 2. And that's still all over x plus 3. This second fraction is 10 all over x take 2 multiplied by all the things there that we're multiplying by. And then because we multiply the left hand side by a bunch of stuff, the right hand side needs to multiply by the same thing, otherwise it won't be equal anymore. And there you go, that is everything multiplied out. Now you should notice that some of these things do in fact cancel out as the fractions. So this first fraction on the left here has an x plus 3 on top and underneath, so they will cancel. And in fact normally you wouldn't bother even writing those, you would just write 14x take 2. And here the x take 2's cancel each other. So once that's cancelled out, this next line is normally what you would write first. So at this point now we've got an equation with no fractions anymore. We've got lots of brackets to deal with, but it's just now a fraction with x's all lined up to play with and mess around with. So let's multiply out these brackets to try and simplify this into one expression. So that gets us 14x take 28 plus 10x plus 30 is 7 lots of. This pair of brackets I'm going to expand first and leave the 7 out. So just expand these two to get that, and then later you can put the 7 in. So this left hand side has got 24x's plus 2. This right hand side has 7x squareds plus 7x's take 42. Okay, so now we should notice this question is actually quadratic, which means we should be able to solve it using a quadratic method, and all of those require having a naught on one side of the equation. So I'm going to take these things away to leave the 0 by itself. So that gets us, the x squareds haven't changed. I'm taking away 24x, so this 7 will become negative 17x. I'm taking away 2, so this should become negative 44. You know at least two methods by now, if not all three, for solving this equation. You could factorise it, you could complete the square, or you could use the quadratic formula. I am going to factorise this because I know it factorises because I set it up, and we've done factorising this recently, so you should be able to. 7 is prime, which makes this quite straightforward to start with. It's got to be 7 times 1 to get 7x. 44's not got a bunch of factors, and it's going to be 11 and 4. 4, 7 to 28. Take away 11 is 17. Deal with the signs now. We want it all to be below 0, so negative 4, 7 to negative 28 plus log is negative 17. There we go, that is factorised. So to solve this, and again you've done this before so I'm going to do it very quickly, you should get x is negative 11 sevenths or positive 4 as your two solutions. Okay, so there's not any individual new steps there. There's just a lot of them in a row, a lot of places you need to concentrate on what's coming next. It's just the length rather than the actual things going on. Right, there's one short thing to show you and then a slightly trickier one after. So here, with this set of equations, the factors aren't of the same type. Sorry, the denominators aren't the same type. Here they're both in linear, x, they're just x with no power involved. Here this one's squared and this one isn't. And in fact, even if they're the same type, there are still things here to watch out for, particularly as this first one factorises. So this is actually 27 over x lots of x plus 4. Now that actually changes what you need to multiply by. As you should be aware of from adding and subtracting fractions, common denominator is quite a useful thing to be aware of with fractions. So you don't have to multiply by everything here. You could just multiply by whatever you need to get a common denominator. So multiplying this stuff up, we're going to cancel and get things simpler. So the x's will cancel here, leaving that with just being a 27. We multiply by x plus 4. The x this x won't be involved in this because it's already here, so it will cancel out. Multiply this side up, the x's will cancel, and it will just be the x plus 4. Everything needs to be here though. So I've skipped out the step there where I wrote all the fractions and cancelled things out. You can do that, and that will always make sure things get wrong. I'll put in one of these as the example. So this one here will have been 3x x plus 4 over x, and then you can see what cancels what's left behind. You could do the same thing here to get what's left behind if you can't do all that in your head. From here it's the same steps. I won't bore you by doing it again. If you do end up doing it, you should get x is a half or -5, so you've got to check your working. That's what the answers you should get. Finally, this one is quite tricky, or at least it looks quite intimidating. It's not massively harder than the others, it just looks intimidating because of all the things going on. So we're going to multiply up by all the appropriate stuff, cancel out the fractions, and when you do that you should be left with x plus 4 lots of 2x take 1 plus x take 5 lots of 6x take 9, and that will equal 6x take 9 lots of 2x take 1. And we've multiplied by these two denominators to clear them out, cancelled out whatever could be cancelled, and we're left with that. So that is like on this first question skipping straight to this line of working. So we've skipped out this middle line here because you don't always need to write it, but if you still need to do that to do this, that's not a problem. But that's what you should get. From there, expand the brackets, collect the terms, it all gets horribly messy. This left hand side has got a quadratic thing added together. You do all that, I think you get 8x squared take 32x plus 41. And the right hand side, I think you get 12x squared plus 24 plus 9. Now, to do this in full, I skipped out 3 or 4 lines of working there. Multiply that pair of brackets out accurately, multiply that pair of brackets out accurately, add them together, you get this. Multiply that pair of brackets out accurately, you get this. Don't forget that they're still equal, so the equal sign is still here. A lot of steps there. That's what you should get. Again, we're going to make this equal to 0 because it's quadratic. So take 8x squared off both sides, you're left with 4x squared. Add 32x to both sides. So add 32x to both sides and you get 8x. Take 41 off both sides and you get -32. This, you should notice, all has a factor of 4 in, so we can divide that 4 out to make our lives easier. So we get x squared plus 2x take 8, and this factorises really neatly in the end. X plus 4, x take 2, which means that x is -4 or +2. So even though it started with this horrible set of fractions here, and we had this horrible middle step and an even longer step I've skipped, our final answer ended up being reasonably simpler, factorised nicely. They may not always factorise in the work you get for practice. They might need the quadratic formula, but a lot of them will factorise to start with, to just give you a hint that it's gone wow, that it does factorise at the end, this reassuring step. So enjoy those. They are a bit fiddly, but they're fun and satisfying to complete. So good luck with that.